Come on, Twitch. All right. Hurrah. Let's go tell the world. Streaming game dev. Gonna do texture generation stuff, so stop in if you want to see how it's done. And then we'll hop on over here, paste it here, do this, pop on over here, and we'll be ready to start. So today I'm not exactly taking a break, but I am just switching gears to throw my my basic, it's been a long time doing just spaceship parts, and so today we're going to build planetary texture work. We're going to do textures for our planets. And this is going to just be us creating a nice set of texture generation techniques and using them. So with that in mind, we're going to set up a planet real quick, which we will then texture. So here's our planet. It's just a circle. We're using the default sphere built-in primitive. We might change that later, but for now it's fine. And we're going to be building a new kind of script, which we will call the planet API here, the planet namespace. So generate planet texture, generated planet texture. And we'll just open that up. So our generated planet texture is going to be in a namespace, just because that's a good way to keep things clean. There we go. And how does this work? Well, basically, we just need to create a texture where it does whatever we need it to do with that texture. So what we're going to do, Cody1712 says, hi, hello, we're generating planet textures today. So what we're going to do is we're going to actually create a new kind of Unity event and just see whether or not we can set this up with just Unity events, because that would be nice. So it's a public class texture event inherits from Unity event. Oh, gotta Unity event texture 2D, and then down here, I don't think I need that. Then down here, what we'll do is we'll say public texture event on new texture. And we're going to see whether or not we can actually assign this correctly. So we're going to create a new material, which we're going to call planet. And then we will drop this planetary material onto our planet, as you might expect. And then over here in our scripts, we will drop our generated planet texture here. And it doesn't look like it actually took. Oh, I forgot to tell it to take. System.serializable. No, that's security. There we are. Come on, pop it up. Pop, pop, pop. There we are. Yay! So what we're going to see is whether or not we can adjust the texture. We can. We can adjust it right here with the main texture. I don't know whether or not that actually changes the base texture or whether that changes the instanced texture, but until we are doing multiple planets, it really doesn't matter. So for now, it's fine. So what we're going to do is we're going to create a texture, and then we're going to set that set this material on the planet to be that texture whenever we do. So to do that, we're going to need to create a new function, public void create texture. And we're going to want to make that something we can call. Come on. Run. And now we're going to need to be able to create it and then post it and all sorts of stuff like that. So let's create all of the variables we're going to need in order to do that. So public texture 2D texture. And then we'll have, we could do an int and width, but I think I'm going to hard code them. But instead of having a public list for our color 32, we're going to have a private list, because otherwise it'll be huge. And, you know, if I ever accidentally hit expand on a list of 14,000 colors, it's going to be obnoxious. All right, so there we are. Here in create texture, we're going to say if texture equals null, then texture equals new texture 2D, and then we're just going to pick an arbitrary width and height, and then we're going to go ahead and say if pixels equals null or pixels.length does not equal texture.width times well, let's go ahead and make that something we can just call. Give me a moment. Public int pixel count get if texture equals null, return 0. Return texture.width times texture.height. And we might as well actually add in all of the values we're going to need. Public int width get return texture.width. Public int height get return texture.height. Come on, stop capitalizing stuff. There we are. And then here we can just go ahead and put that in. So then here we can say if pixels.length does not equal pixel count, then pixels equals new color 32, and then pass it the pixel count. There, now we've set up our blank canvas. We've got a texture and we've got a bunch of pixels that currently don't have any colors in them. Now, in order to fill this with colors, we're going to need to use a noise field. So rather than actually using just the built-in noise field straight, we're going to want to farm that out so that we can replace it later. And I'll show you what I mean in a moment. So for int y equals 0, y is less than texture, or less than height, y plus plus, and then here we'll go ahead and say for int x equals 0, x is less than width, x plus plus, and then we'll go ahead and int index equals y times width plus height. And we could actually make this a little bit more efficient, but unfortunately for us, the efficiency of this loop is negligible. I mean, even if it took a long time, it wouldn't matter, because what really takes a long time is the noise field generation, and we're going to be doing that a lot, which is why we're going to want to optimize it later. So what we're going to do here is we're going to want to pass it a value, a color. So we're going to want to say that our pixels index equals a color. So how do we do that? We'll go ahead and say get color, and then we have to pass it a coordinate that we're trying to get the color for. So in this case, it's going to be x and y. But here's the thing: we don't pass it as two separate integer values. Instead, what we do is use a vector2. And the reason for that is because we're going to be using a lot of float math, and I don't want to do any int work. I want to be able to just pass it around willy-nilly. So here we'll go ahead and say protected color 32 get color vector2 pause. And now what we could do is we could say that we're just going to generate a new color based on the math noise field. And that's what we'll do just to get started. So float q equals math f dot noise. Perlin noise is, I think, the only kind of noise we have built into Unity. And we can pass it the position, but we're going to want to multiply the position by a scaling factor, because otherwise it's going to be wrong. We're also going to actually call this scale 0, because there's going to be a lot of factors, and we want to make sure that they're all separate. So public float scale 0 equals 0.002. That should do. F. And then we're going to just return color32.white, color.white times Q. And that will allow us to create a really, really fast and easy value that ranges from a transparent black to an opaque white. And since we are using an opaque shader, that's not going to matter. So the Perlin actually takes it as two separate values. I didn't realize that. There we are. Good. So now what we'll do is we'll go ahead and say run. And it says array is out of range. So we screwed up with something stupid and basic. That happens. Here we can see that what the problem is I forgot to say X and instead said height. Yep, it was something stupid. It's always something stupid. So if we look at the texture, you can see that it's just white, a flat white field. And the reason for that is because we forgot to actually put the pixels into our texture. So texture.setPixels, and then the pixels. We also have to tell the texture to apply that difference. And that's where the real slowdown is. The two things that are slow is this and the math. So what we may end up doing in the long run is creating a mip-mapped version, which we can just create each mip-mapped tier in sequence. But that's an optimization we do not need right now. So we're not going to do it right now. So now if we generate it, boom, you can see that we have a blobby field, but it's hard to see here on the sphere. Now, I don't know if you can see that on YouTube or not, but there is, in fact, something there. But I think the problem is that this is so stretched that we can't see it. So we're going to actually go ahead and do 0.002 and see what our... Okay, so now it's just flat gray because that's too low. So I'm trying to find the sweet spot without having done this. We're using a primitive, and I'm not familiar with the primitives. No, it's not using... Well, I don't think it's using the right texture. Maybe this only works in run mode? That would be obnoxious. Well, let's go ahead and try it. It doesn't appear that it's actually submitting the texture like I want it to. That's kind of a shame. What we're going to do is we're going to not use the material event that I was using, and we're instead going to just have it target a material of choice. Now we're only going to want to target our local material here. So what we're really going to want to do is use a material property block and change the main texture using just a property block. So in order to do that, we're going to want to also keep track of our mesh renderer, because the property blocks are applied to mesh renderers. So now what we'll do is we'll say if MPB, I don't think these can equal null, I think they're structs, but we'll go ahead and be safe. MPB equals new. Actually, I don't even need to, they're real cheap, unlike the others. So we'll say new material property block, and then we have to tell it what properties we are trying to give it. And there are a couple of things we can set, and texture is one of them, as you can see here. However, we're only going to want to do this at the end when the texture is actually done. So we're going to want to set the texture to, I think it's called main texture, but I'm not sure. And then we're going to want to pass it the texture. And then we're also going to want to set our target renderer to use that property block. Boom. Like so. And that should work in theory. We just have to set up our target texture, our target material. There we go. Target renderer. My bad. So now if we hit save, oh well, that's fine. We'll save it as planet. I hit save just because I haven't actually saved this scene yet. It's basically empty. Now let's try it one more time. I'm not at all sure that this will work in this mode. As you can see, it doesn't display the material property block. It's a little hard to tell whether or not this material is properly being updated. Now the problem is, this is definitely not a good enough texture for us to be working with, and it's hard for us to see exactly what sort of values we're coming up with. Maybe I have the scaling backwards. Let's just try it out here. Yeah, I had the scaling backwards. All right, so that's fine. So you can see now we've got a real tight crawling texture, and that's fine for a start. We're going to want to assign this to the material, and it's not taking. Maybe this isn't called what I think it's called. Let me just look it up. Property, Unity, property, block, main texture. Underscore main text. Did I spell it main texture? That's what the problem is. That's why I wish that these things were much more clear. There we go. Perfect. All right, and the greatest thing about this is that because this material property block is being overridden like this, we don't have to worry about it screwing up and creating hundreds and hundreds of textures, or hundreds and hundreds of materials, rather. But you can see that we do have a problem. The north and south pole of this planet are busted, and this is not actually an ideal round ball either. It might be worth us going and getting a different ball shape later on, because this one has some edge problems up here, as you can see. But there is a crease down the side, and there is a north and south pole problem with it stretching. We're going to have to deal with those, but first we're going to make it so that this isn't just a blobby mess of random dark colors. There's actually a lot of easy ways to do that, and that's what we're going to do for the next half hour or so. I hope you like finding out about colors and random textures, because that's today's job. So here you can see when we get the color of a vector2 position, we actually only return a value Q, and that's just like a single grayscale value. Our first task is going to be to get that grayscale value to be better. So first thing we're going to want to do is have that grayscale value have its own function. So we're going to call this a noise, and we'll pass it in a vector2 pos. And we'll just return mathf.purlin noise pos.x pos.y. Now the reason that we are putting this short little function into play is because we're not going to be using the Purlin noise generator as it is forever. It's a little slow, and it's not cached. So it's a little bit better if we can do something a little bit more fancy later. But we're also going to want to do some cool techniques for making this look skewed. So for that, what we're going to do is we're actually going to grab the noise value in two different places. So we're going to grab it at the position, and we're also going to grab it at the position plus an offset. And then up here, we're going to define that offset. So protected float, that's not a float, float offset 0 equal, or that's not a float, it's a vector2. There we are. Equals a new texture to vector2, and then just some arbitrary numbers to start with, 1.1, 0.1. Doesn't really matter what they are at this point, because we're going to be randomizing them. So in order to randomize them, public void randomize, and we'll just say scale 0 equals mathf.random, random.value, I'll remember where this stuff is, times a small value like 0.01, something like that, right? And then we'll say offset 0 equals random dot within unit sphere, unit circle. There we are. And then we will just go ahead and set this to actually create a texture. And that's also something that we're going to want to do from a context menu. So with that in mind, when we offset like this, we'll get an X and a Y value. What we can do is instead of returning, Cody says it's squashed because of the UVs, right? Yeah, this is a big deal. Planets, and includes the planet Earth, maps are not, they're square, and the planet is not square. So up at the top of the map, there's a lot more texture space per pixel of real planet space. And that's true on real planets, which is why a lot of the maps you see have like weird cuts in them. So what we're going to be doing is we're going to be creating a stretched version of this later on where we stretch out all the coordinates properly. But that's really easy once you know how, so we're not going to fuss about it too much at this point. So we're creating an offset value here. We got color.white, and that's not what we're going to want to do. Instead, we're going to want to return a color that's based on the X and Y values. So protected color 32 get color. And this is actually going to be a vector 3 for reasons that we'll talk about later. But we'll want to return a real color. So get color new vector 3 x, y, 0. And we probably shouldn't use the term get color now that I'm thinking about it. We'll call it colorize. Because it's the same name, and they're not doing the same thing. It's not just a different version of get color. It has a fundamentally different purpose. So the way we're going to do this is color 32s take bytes. So we're going to want to grab a byte version of the vals.x, the vals.y, and the vals.z. But in order to do that, we need to be able to grab that. So protected byte ftb float. Here we'll say if f is greater than 255, return 255. Otherwise, if f is less than 0, return 0. Otherwise, return, I guess we want to f times equals 255 here. Return byte mathf dot round to int f. There we are. So here what we'll do is we will say float to byte vals.x, float to byte vals.y, and float to byte vals.z, 255. And that will give us an arbitrary color, so return color. And that color will be based on a couple of different features. As you can see, it's based not just on X and not just on the position that we're actually at. This pause is the position we're at on the planet. Pause plus offset is some amount off to the side. So right now what we're doing is we're getting two values and we're making them the red and the green value. And we're gonna just be playing around with this a little bit. In the end, it's gonna be largely random. But you can see that what we get out of this right now is a block of yellow, which is no surprise because it is just the RG being RG is yellow. So when we max out the red and the green, we get something yellow. But I'm a little bit concerned because it shouldn't have maxed out those values. Those values shouldn't be 255. The noise should only be between 0 and 1. This returns a value between 0 and 1. So float x should be either between 0 and 1. Float y should be between 0 and 1. So multiplying them by 255 shouldn't give us... Well, this is odd. Come on. You done? There we go. Ah, there we are. For some reason, they are already Oh, that's strange. Why are they going between 0 and 255 by default? Oh. Fucking idiot. I forgot to actually tell it that we were using the version that takes bytes. So it was taking them as float values. And it was like, why are they, what are you talking about? So now I'll run this again. There we are. That's a little bit more like what I expected. So what we have here is a very basic setup for creating a blurry set of values. Now you might not be able to see exactly what's going on here because I've been keeping it vague. So what we're going to do is we're going to go ahead and make the Z value equal to the X and the Y value combined, just so that you get a stronger impression about what's going on here. So red, green, and blue, any place on here that is blue is both, and then you get the red and the green separately. What we're going to end up doing is using these colors as guides rather than as blurred elements. So if the green is greater, then it'll be like an ocean or something. But we're not ready yet because these values are still too vague and blurry. They still don't feel right. You see this? How it just looks kind of like a blurry mess? We need to offset by more than that. Also, I think that this offset here is a little bit too low, so we're going to go ahead and multiply that by 4. Cody says, isn't it going to be difficult because procedural materials can't fit seamless at the UV cut, or can they? Oh, we'll just make it seamless. That's no big deal there. There's a couple of things you can do. The first is we could just put the seam on the far side of the planet. But the second is that it's not very difficult to create a planet whose seam is properly done. All you have to do is change how your texture works so that you bounce. And there are lots of different ways to do it, but you can smooth over that texture either by just bouncing so that you have two seams that both match up, or by using a more complicated method. We'll probably just use the bounce method for now because it's easy. All right, there we are. So there is the blue that I was talking about. I don't know why that took so long to get for some reason. But what we're going to want to do is we're actually going to want to offset by substantially more than these values. This is just one offset level, and it's not even how we're supposed to do it. So what we're going to actually do here is we're going to get the values based on these X and Y coordinates right now are just our flat colors. Those are actually going to be the X and Y coordinates that we feed into the noise field. So here what we're going to do is we're going to make, instead of this being X and Y like this, we're going to make the value here equal to the noise based, I believe it's based on X and Y. Let me just go ahead and pull this up in my other screen so I don't screw this up. Because I did this before, but I can't remember this little tweak, whether I do it one way or another. Yeah. So we're not actually getting the real X and Y values. We're getting X and Y values based on the X and Y values that we are generating. So the noise that we created is not actually what we are getting here. Let's go ahead and make this Z. When we say get the noise at position X and get the noise at position Y, we're passing POS into our field value here, and we're getting back a value between 0 and 1. Then we are getting Y, which is another value between 0 and 1 that's slightly offset from the first value. And then we are actually getting the noise field at that new coordinate. Now the reason for that is because it allows us to mix and match our setup here. Oh, and Supercan has an easy way to make this work a little bit better. mathf.clamp f times 255, 0, 255. Yep, thanks, that's a lot better. I'm not used to thinking like that. There we are. We misspelled something. So now that we are getting a different set of values, we're not going to see anything like this. We're not going to see anything like this now. We're going to see something very, very different. And it's going to be too blurry. Okay, so the problem here is that our scaling is wrong. We have something that works, but it is scaled so much that we have an issue. The problem is that all of our values are now between 0 and 1. X is between 0 and 1. Y is between 0 and 1. So when we look for the noise value here, we're getting a noise value between 0 and 1 for both of these coordinates, meaning that we're stuck in that first little 0 to 1 block of the noise field. So what we're actually going to want to do is have a second scaling operation where we will multiply by some amount. Let's go ahead and say 20. And then what we'll do is here, we're going to multiply this by our scale. And that should compress this down rather dramatically and give us something that feels a lot more powerful. So we'll just randomize this again. All right, so now if we take a look, you can see that we're starting to get something that's looking kind of fun and creepy, right? Woo! Halloween spooktacular time. So this is an easy way to do what we need to do. There are some things that we're going to want to do here. The randomizer needs to have this new value stuck in there. Scale 1 equals random.range 1050. And we're also going to want to do actually more than what we just did, which I'll talk about in a second here. So now you can see we're getting all sorts of strange patterns here. And that's sort of what we're going for. But these strange patterns don't look very planet-like exactly. They just kind of look weird and stretched and skewed. And that's just because of the fact that we aren't correctly getting those randomized offsets. So if I grab back over here and just take a quick little look, what we're actually trying to do here is we're manipulating our position. We pass it in an XY position. And what we do is we get out of that a different set of X and Y coordinates that's based on the noise field. If we do that twice, then we have a double offset, and it gets to be quite mixy. So what we've got here is a very basic thing where we do it once. What we're actually going to want to do is have that be something that we just do as a matter of course. So protected, I guess we're going to not make it a function because I have to pass offsets and that would be annoying. So vector2 new position 0 equals new vector2, and then we'll pass it in the noise of the position and the noise of the position plus the offset 0. And then vector2 n1 equals new vector2 noise position plus offset 1 and noise position plus offset 2. We don't have those yet, but they're very easy to make, so it's not a big deal. Let's go ahead and make them now. And as always, our randomize needs to be updated, so we'll just do it. Also, those might be too small. Those 4s might have to be substantially more than that. Also, we're going to go ahead and I guess I don't want to change it. I was going to change the scale to a the scale 0 is currently very small and the scale 1 is currently very big. I was going to equalize that, but then I'd have to introduce a division, and that's a little bit expensive, so we're not going to. So now that we have 2 sets of vectors, what we can do is we can get a final value based on our 2 new vectors. And we can, and we can get this offset by some multiple, just because if we don't use a multiple, it'll end up very, very repetitive. So if we do it like this, we'll end up with something that feels fresh. So let's try it out. Have you done recompiled? I was supposed to make a recompiler warning, but I forgot. Soup of Ken says, any reason you're generating a texture on the CPU instead of doing it in a shader? Mostly because I'm not comfortable enough in a shader to do this. In the long run, it probably will be in a shader, but it's really easy to change between the two, I've been led to believe. So what we've got here is an issue where this value is too high. So what we're going to want to do here is make this so that it's substantially less likely to be that. Oh, wait, no, that's not the value. Well, they're both too high, aren't they? That's fine. Go ahead and make this 20 and 50. That's a little bit better. And if you take a look here at the texture, you can see that we've got something that looks fun and a little bit unusual and kind of creepy that we could use as an asteroid or a small planet of some kind. Obviously, the black to white stuff isn't what we need to do. What we need to do is some color, and we also need to sharpen these edges and a couple of other details like that. So I still have some outliers where the values end up a little bit too soft, because this would be a real tiny asteroid, right? So I think what I'm going to do is I'm going to change this scale to multiples instead of divisions. And then down here what we'll do is we'll just calculate it out by dividing it once and then use that multiple throughout. So float scale factor equals 1 divided by scale 0. There we are. Oh, and then we have to change the randomizer because that would otherwise be very stupid. Now, hopefully that'll give us a little bit better values, or at least a little bit better control of values. I don't know about you, but I can more easily think about a value of 100 rather than a value of 0.001. It just is easier. Yeah, that's a little bit better. But Soup of Ken, if you are real good at shaders, I wouldn't mind taking a shader from you. But until I figure out the best way to do them, I've got to finish this code here in here. One of the issues I've got is that there are a lot of things in the generation of the texture that I'm not sure are shader friendly. The biggest problem being if statements on which colors to use. I have done shaders before where I use a lot of lerps. I'd have to use a ton of lerps, and it would make things really more complex than they need to be, at least until I figure it out. Now, the problem we've got right now, this sphere isn't very well UV mapped, and I think it's time for us to generate a new sphere that is a little bit better UV mapped. We'll go ahead and put it in stuff. So we'll just drag this stuff aside for a second and add some new stuff. So what kind of planet you want to use is up to you, but I think that a UV sphere is fine for nearly all of our needs. The only problem with a UV sphere is that it's not actually UV'd, as you can see. So in order to make it a UV sphere, we've got to unwrap it properly. But you can see that when it unwraps, it gets into a different format. What we really want to have is a format where it is perfectly square, even though that does create some offsets that don't quite work. And I'm not actually sure which of these is... I know there is a way to do it, but I've never done it in Blender. So I'm not sure if there's a way to do it in Blender. Dopbow says, hi, it's been a long time. Hello. Today we're taking a little bit of a break from making spaceship parts and we're making planets, but I've forgotten how to unwrap a circle or a sphere. Because that's obviously not, I mean, it's not the worst possible format, but it's not good. All I want is a perfect square unwrap, and I've forgotten how to do it, if it was even possible in Blender in the first place. None of this is working. This is not correct. You can generate the UVs when creating the object. Let's try that out. Generate UVs. You are correct. I can. And that does seem to be right-ish. That's an unusual set of UVs, but it will work for us. So we will name this... Come on. Low poly planet. And then over here in Unity, we'll go ahead and set that up here. Low poly planet. You can see it's double the size of the old one, but I don't really care. And we'll go and reset the sphere collider so it doesn't panic so much. You can see that it's turned on its side in comparison, which we'll fix right now. Superfican says, can't you use a subdivided icosphere? UV spheres are for plebs. Well, I'm not doing anything that requires a subdivided icosphere, although the reason I avoided it was because I didn't want to have to generate UVs. And as you can see, the UVs you get from a divided icosphere, you'd have to massage them a lot to make them work. So it's either use this sphere that works just right off, right from the start, or spend a lot of time massaging an icosphere to have it have the correct UV coordinates. So, I mean, I could build the icosphere myself, but that seems like a lot of work when this works fine. So there's not really any reason for it. Dapa says the best way is to subdivide box and shrink wrap on sphere. That's not a bad idea, although I have some suspicions about some of the UV coordinates and the way that will work. This should work fine. I don't have any problem with it. All we need to do is make it so that our coordinates are correctly mapped into the stretching values of our sphere. Down here, when we say get color and pass it a vector to pause, what we need to do is figure out what that vector to pause is in UV coordinates, because right now it's in circle coordinates. And you can see here we multiply it by a scale factor, so this is actually where we need to do it. There. So convert to UV coordinates to avoid stretching. Basically, the further away from the equator, the shorter the x-axis is. So that means that the more distant from 0.5 the y value is, the worse. So up here in y, we're going to start to calculate that. Float, and we will go ahead and say x scale. And we're going to want to have that be based on the y value as a percentage. So y divided by equals height. Dotpa says, is there any way to make syntax highlight in the shader file? Sure, just use a system that's familiar with shader code. I'm not sure if C# is. I'm not sure if Visual Studio is, because I've never tried it. This does do quite a bit of highlighting in shader code, so I've never had a problem. But if you want to see that, here, this is what it looks like. Shader code looks like in my monodevelop. It's all highlighted just fine. So what we're going to want to do here is the x scale. Idiot. So what we have now is x scale between 0 and 1. So now we're going to want to say x scale equals x scale times 2 minus 1. And we're going to want to make that mathf.abs. Now x scale is correct. It's between x scale, still between 0 and 1, but 0 is no warping. So now what we're going to do is we're going to go ahead and square it, I think. Yeah, I'm pretty sure it's squaring it. X scale times equals x scale. And then x scale equals 1 minus x scale. And that should be right, I think. We're going to go ahead and find out right now-ish. One of the things we're also going to want to do is change these to floats. And the reason for that is simply because otherwise we'll have to do a crap ton of casting. Oh, dot bomb and autocomplete. No, I don't know if I don't think either one does autocomplete for shaders because they're not built to do shaders, and I don't even know whether Shader Toy uses autocomplete. You can try it out and find out. But looking at docs every time is basically what I assume everybody does. Shaders are sinister magic. All right, so, you know, I think I might have accidentally inverted this. We'll find out. I don't think I inverted it. I think that's correct. Yeah, look, it's correct. So now the only problem is that our x value isn't stretching evenly away from the half mark. It's stretching off to the right really, really fast. So what we're actually going to want to do here is have the x value be based on the distance from the middle of the planet, or from the middle of our image, just because that'll reduce stretching. So we're going to go ahead and make this x minus width divided by 2 times x scale, I think. Are you done with compiling? Oh. There we are. That's a little bit better. Now we've only got the offset away towards the outsides, as you can see. That'll prevent the stretching from getting really, really bad. And it'll also be handy for us to be able to sync up the edges later on. Dotbow says, is it for background or can the player land on it? Well, for now it's for background. But the same technique can be used to allow for players to land on them, because you can simply use the same offsets. And then your offsets can grow more and more detailed as you go down, and you can add in more octaves if you need to have some more density. So it's a very flexible technique which allows you to really rapidly create as much density as you need whenever you need it. And you can see that it doesn't look too bad, but it does look random. It doesn't really look like it has the sort of planetary features that you want. Also, it is a little bit stretched to the back end, to the back edge, see? So what we're actually going to want to do here is, this seam is getting on my nerves. Shall we erase it? We're going to erase it by doing, we could either bounce or we could do a bleed over paint. I think we'll do a bleed over paint. Soup of Can says, these might come in handy if you're interested in doing the texture on the GPU. Yeah, I have looked up how to do it on the GPU, although your link is busted. But the... Yeah, new lines don't get pasted. Sorry. I have looked up how to do it on the GPU, but the amount of fiddling I've got to do to make this look like a planet is something I don't want to do while I'm looking at GPU code, because GPU code is obnoxious. So what I'm planning on doing is having it all worked out here, and then I can convert it over later on into shader stuff. Because the logic is the same. The only difference is that I have to change some if statements into lerps. And that's something I can certainly do. So, you know. What we're going to want to do here is... I'm also concerned about making the GPU code have to call random too much, because I'm not at all sure that that is properly fast. Well, we'll figure it out later. Oh, there's an extension for shader code, says dstu99. That's great. So if you're using Visual Studio, you can grab the extension in the and have it so that it auto-completes for you, which is fantastic because that's one of the most obnoxious parts. Anyway, What we're going to do now is change the color values, and we're going to do this based on a couple of features. Here we have the N0 and N1, and we've been returning just a flat Z value, but what we're actually going to want to return is a little bit more than that. So what we're going to do here is I'm going to say N0 plus magnitude, Z plus N0 dot magnitude, and Z plus N1 dot magnitude, just to give us a little bit of color variation, and that should be fine. Oh, I was gonna erase the seam, and that's right. This is not dense enough. Run again. But I guess this should probably be minus. There we are. So the code here that we're going to want to reduce, we're going to want to erase, we're going to end up painting pixels from the other side of our equation. So here we're going to actually be taking the equation for both x of very negative and x of very positive. The alternative is, because this is x is 0 over here, this is x 0. So the two basic ideas are we can either take the absolute value of x and then do a perfect bounce, which will look a little unnatural, or we can simply paint when our x is really, really far from being positive, from being 0, we can paint the other half as well. Visual Studio Code. I'm sorry. I don't really know the difference. Dabao is wondering why I'm doing shader stuff on the CPU. I'm doing all the stuff on the CPU because it's not shader code. I'm going to be doing a lot of stuff with this, like putting in ice caps and stuff. So it's really a pain in the butt to be looking at shader code for that every single time. Dabao says, is it linked to the shader somehow? It will be. There's no reason to explore stuff in shader code unless you're so comfortable with shaders that you can just feel good about that. I am not that comfortable with shaders, so I am not doing this on a shader. It would take me forever to do all of the fiddling I need to do while looking at, code where you're not supposed to use if statements. So we're gonna do this in the CPU for now. It's not like there's a big deal here. These are just visual glitter. There's not really, it's not really going to be a heavyweight part of our game at this point. Later on, we'll be able to fix it up. So what we're going to end up doing here is we're going to pass in a vector3 pos into getColor. Because what we're going to want to do is pass in the position of the other half of x, the raw x position. So here we are. But that does mean that we're going to want to multiply the scale factor for only the y and the x coordinates. And then the z will be the raw x factor. And that will allow us to figure out exactly how much blurring we want to do. Dotbao says, sounds very handy, but it's been so long that I don't actually know what he's talking about. So the further we get away from 0, the more we're going to want to paint from the other side of our equation. So down here in our getColor vector3 pos, we're going to want to have this be actually still just a vector2. We're going to want a variant that's a vector3. And what we're going to want to do is pass it the first two values. So color 32 main equals getColor pos. And then we're going to want to then make it so that we get a backup color based on how far away we are from 0. So we're going to want to make this a absolute value. And then the closer to 1 it is, the better off we're going to be, or the more of the other color we're going to use. Float mix equals pos.z minus 0.5 times 2. And then we'll go ahead and say mix times equals mix times mix. And then what we'll do is we will just grab a if mix is greater than 0, color 32 other equals get color new vector2 pos.x, negative pos.x and pos.y. And then we will mix them together. So main equals color 32.lerp. And then we will get the original and the other and the mix value. Return main. Yeah, see what you're talking about, Supafcan, is why I'm not doing it in a shader. Oh, because this is supposed to be a vector 3. Yield. Yeah, pos.yield my butt. Just pos.y. Why would it be yield? That was a strange autocomplete that you pulled. All right, there we go. Oh, that didn't work. Stack Overflow, huh? Ah, so here we got the problem. I'm passing it. Of course, I forgot to tell it that it had to cast it to a vector 2. I could just go ahead and say cast it to a vector 2. So it was literally just calling itself because I was an idiot and forgot what I was doing. So basically what we're doing is we're passing the vector 2 version. When you cast to a vector 2, it just chops off the z-axis, which is what we want. And now we'll try it one more time. All right, so that did not work. It doesn't appear to have done anything, which is not what I had hoped to see. So in theory, mix should be between 0 and... Let's go ahead and say just... Let's just create a lot of spam here. Debug.log mixing. We'll just go ahead and see whether or not it is mixing at all. I guess we'll put the mixing value in. Now this is going to be a lot of spam, so that's why I was hesitant to do it. I could reduce the number of pixels involved, which would help. Yeah, okay, let's do that. This is a little bit too much. The amount of spam involved is ridiculous. So we'll go ahead and create these. Public int width equals 1024. Public int height equals 1024. You can delete these now. There we are. And then down here, we'll tell it to do the proper thing. Width and height. Perfect, right? Grind, grind, grind. And what we're going to want to do is change this to, say, 64, just so that we can test it out. Boom. Here you can see that we've got mixing values of 42,000. Okay. I forgot to actually make this a percentage, so that's the problem. What I need to do is not divide it by 2, but divide it by width. And that'll make it between 0 and 0.5. So what we're going to want to do here is say 2 times that. And that explains the problem. Dopao says, I really want a second texture for moving like clouds. That is absolutely in the cards. You bet. All right, so now we are getting a mix, but as you can see, it is a little bit odd. It might just be because I've lowered the texture so much. If we take a look, you can see that it's just not very dense at the moment. And that's probably just because the texture is so small. We're going to take this here. Where is it? If texture equals null, or texture.width does not equal width, or texture.height does not equal height. So let's go ahead and bump that back up to 124 and give it another shot. D-Stu says, won't width divided by width equals 1? Are you talking about width? Here, I guess I probably should use some brackets to make sure it doesn't screw up. I could also do x divided by width. Yeah, I guess you're right. That would be easier, wouldn't it? X divided by width minus 0.5f, or times 2 minus 1. That's what I get for just revamping existing code instead of making it work properly. Oh, and I need to take out the debug log, you idiot. Good catch. You're paying more attention than I am, D-Stu. Come on. Come on. Oh, I knew that was going to be too much code. I'll get water while I'm waiting. Maybe I'll check my mail. Oh, someone uploaded a video. How exciting. Oh, it was me. Anybody on Twitter saying that I am doing things wrong? It seems unlikely. Oh, come on. This was a bad idea. Oh, I really screwed the pooch on this one, guys. So I think the real problem here is that I told it to debug every single pixel, and there are 100,000 of them. So, or is it 1 million? I think it's 1 million of them. So it's now printing 1 million lines to the debug console, and it doesn't like that very much. Now I could crash it, like just kill it manually and then start it up again. But I think I would lose some progress if I did that. Oh, that was dumb. That was just the dumbest. Okay, well, I know that I fixed the, I saved this. It's not something I have to recreate. So we're just going to go ahead and kill it. Oh, I've got to kill it good. No, that's OBS. Don't kill that. That's the console window host. You shouldn't be running at all. Oh, that's interesting. I'll look into that later. I wonder what started up the console window host. And now we'll bring that back up as Unity again. All right, now I'll open up the correct directory. Ignore Unity barfing again at its attempt to log me in. Unity's, in case you're wondering, don't ever pay for a Unity service. What do you call them? License, because their licensing system is actually worse the more you pay. So be aware of that and don't pay them. There we go. So, can you tell where our cleave is? You can. It's right here because it didn't work. So the question is, why didn't it work? It should have, but it didn't. So let's go ahead and give the height like a 6. All right. So wait, this doesn't look right at all. This looks like it's even stretching wrong now. What's going on? Oh, it's the wrong mesh. There we are. Better. All right, that's more like what I wanted to see. I was wondering why it wasn't working. I was like, this should work. I didn't do anything wrong except for burp straight into the microphone. All right, so here you can see that we do have a seam, but it's something we're going to debug right now. Hello, Mr. Seam. So it looks like what I'm doing is I'm an idiot. I forgot to blur it. This mix needs to be divided by 2. So that at 1, it's half and half. Because right now what's happening is they're actually switching sides. Rather than blurring to a nice seam. So hopefully that'll fix it. It looks like a bowling ball. Yeah, it's unfortunate, but that's the sort of thing that's going to happen until you figure out how to get this stuff to work. So now it's got a little bit better setup. Now I'm not sold on everything I'm doing here in terms of how I'm making it look. One of the things that I think I'm going to do is have another scaling value. We're going to call this one skew factor. And we'll go ahead and make it 10. And then down here, we're going to make these skew factors. And then here we'll say skew factor equals random.range 1, 20. Because right now it doesn't look quite, it looks like a gas giant, and that's not really what I want out of it. Yeah, it still looks pretty gas giant-y. So now what we're going to start to do is introduce colorized elements. So what we've done is we've created these colors that are between 0 and 255 on X, Y, and Z. X is red, and that is the primary height, whatever you want to call it. It's the main height component of the map. The problem with this is that it doesn't have very much in the way of internal grain. There's no small scale wobbling, so we may have to introduce some of that. Y and Z are both offsets from that, the downgrades of that, depending on certain other values. What we're going to want to do is use Y and Z a little bit more interestingly, and we're going to want to try and introduce some smaller values here. So if I reduce the skew factor rather considerably, what does that give me? Oh, well, I have to... So when the skew factor is low, you get very gentle lines. I'm not sure whether I believe what I'm seeing, though. Because the skew factor is the part I don't understand in terms of how it's going to make planets look. So that's a skew factor of 6. And that's a skew factor of 42. And I can barely tell the difference in terms of the crispness of the lines. But it looks like a higher skew factor leads to a more distorted, wobbly look, whereas a low skew factor gives us more of an asteroidy feel. Yeah, that seems to be the case. It might just be me hallucinating, though. Supafcan says, why don't you just vary the skew factor? Well, the problem is the skew factor is being applied to these offsets. And what we're going to want to do is move that down into the runtime thing here. There we are. Now I can vary the skew factor and nothing else, which is nice. So let's bring this down to, something low. I have a feeling it's going to look completely different. Yeah, it looks pretty different. But I was probably wrong because this also looks pretty wobbly. Oh, I didn't mean to hit randomize. That was dumb. All right, so if I take the skew factor here and move it down to just like 6.5. I can't say that there's anything about this that... It might just be random noise, and it's not like there's a value that makes any sense. Well, if it's over 1, then it should be just random noise. Because the skew factor is offsetting a value that's between 0 and 1, or between -1 and 1 on each axis. So if it's over 1, then it's more than 1 unit wide. If it's less than 1, it's going to be less than 1 noise unit wide, less than 1 octave wide, and it should end up looking like that. Whereas if it's like 1, yeah, the instant it goes above a certain value, which is probably around 0.5, it's going to just be noise. So it doesn't really matter what the skew factor is, I think, as long as it's not teeny, teeny, tiny, tiny. Let's go ahead and just make it between 0 and 10. Anyway, the X and Y values that we have right now, they're being converted into green and blue with a certain kind of offset. So what we're going to do is we're going to make that not an offset. We're going to make that just flat out the way it is. And the reason for that is because that color is not the color we're going to actually use. But those coordinates should give us an interesting overlay. If we look at this same thing set up that way, you can see that we have a different set of values here. Now, the green and blue portions of this color field are substantially more large and blurry. So we're using the red portion to identify the sharper aspects of our planet. And these will be more like biomes. The green and blue will be more like biomes. To tell you the truth, we could do any number of values. It doesn't have to be 2, but 2 is a good set of values. Right now we're returning a color, get color, blah, 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 blah. We're actually going to want to make this something that returns something that's a lot more than a color. And I think that we can... What if I make this X and Y? Or X and X, I guess. I'm just going to check and see whether or not this skews properly on all axes. Yeah, so what we're actually going to want to do is return a 5-factor element instead of a 3-factor element. I don't believe that a vector 5 is a thing, though. No, vector 4 is the biggest built-in one. So basically, I'm thinking the problem is I've got to have biome factors. And so what I think I'm going to do is I'm going to go ahead and take a mathf. I'm going to be using a vector 4 for storing these values and then converting them over into a color. So in order to do that, we're going to want to protected vector 4 get biome data vector 2 pause. There's going to be cleanup to do after this just because of the way it's going to work. But we're going to go ahead and say vector 4 biome equals get biome data, pause. And then this stuff is going to be in here. And what we're going to do is we're going to return a new vector 4 based on these values. So new vector 4 biome equals new vector 4. I'm just an idiot. Vector 4 biome. And once we've got that, we'll fill in these values. Biome.x equals z. Biome.y equals n0.x. Biome.z equals n1.x. And then biome.w is going to equal either n0.y or n1.y, but if it's n1.y, it's going to be inverted. So equals mathf.abs n0.y. That's not how you spell n0. But it's going to be mathf. It's not going to be max there. So if n1.y is greater than biome.w, if math.abs n1.y is greater than biome.w, then biome.w equals n1.y negative. That way we can store two primary biomes and a tertiary biome in this data. And we will be fussing with this even more than that later on, because the x and y coordinates themselves are biome data, like the raw x and y coordinates. So that's what we're gonna be having fun with there. So here in Colorize, we're gonna want to pass it a vector 3 that's based on what biomes it's got. But Colorize is currently just garbage. All it does is translate into clamped values, as you can see here. So what we actually need to do is come up with colors for the various biomes. Public color 32, biome 0, biome 1, biome 2, and biome 3. There we are. And so down here, what we're going to do is we're going to use those as our colorized value. So here, this is going to be a vector 4, and we are going to take it based on all of those biomes. Now, we actually need a base color, but our base color is going to be a uniform black, or perhaps a uniform white. I haven't decided. So color 32 call, this is going to equal a lerp between a lot of values. So it's going to be color 32.lerp, and then we're going to go between biome 0. I guess we're going to want to do this with if statements. I was thinking in terms of how it's going to look as a shader, but I think I'll just use if statements for now. Color 32 call equals biome 0 equals white, color dot white. And then we're going to go ahead and say if oh no, we'll go ahead and make it color.white times vals.x. If vals.y, well, we'll say col equals color32.lerp, col biome 1, biome 0, mathf.abs vals.y. And then again, and I know that this does not produce equal blurring, but that's fine by me. I don't care. And then we're going to say if vals.w is greater than 0, biome 2, otherwise biome 3. There we go. And we're going to want to pass those values in, so we'll just pass it the biome. Save. And I think I must have done something wrong there. Yeah. I knew that there was at least one thing that I'd forgotten to fix here. So I forgot to return the biome. Easy enough. There we go. So now we've got these colors here, and we're going to go ahead and set these up the way we want them. So we're going to take it in as a set of colors. White, that's going to be ice, maybe. Let's go ahead and make a kind of a light blue, and we'll have a kind of a grayish brown, and then we'll have a really dusky yellow, like that. Something like that, just to test it out. There we go. And you can see how this is going to start to look like planets. Now, this particular randomized value is not the greatest. That one looks like it's got a cloud cover on it, doesn't it? But it doesn't. Those are snowdrifts. So you can see how this is working. Now, if you're wondering about this super crisp edge here, these are biomes 2 and 3, the latter two biomes. These biomes are the one where I say if it's greater than 0, do this. If it's less than 0, do that. Because of that, they have extremely crisp edges. And what we're going to do is we're actually going to introduce some edge factors to all of them. So here we're going to say if mathf.abs vals.x is greater than 0.3, then do this. And that's going to create a nice crisp edge. But not so crisp that it's uncomfortable. This is supposed to be Y. My bad. This is supposed to be Z. And that way, we're going to see the same value here. I'm just going to run it again with the same values. And instead of having those really, really foggy clouds, we'll have a much crisper setup. Won't we? Won't we? No, we won't. Oh, I barfed. Hold on. Oh, once again, stupidity. All right, now we're going to try that one more time. Come on, finish recompiling. There we go. You can see that now they're a little bit crisper. We can make these as crisp as we want, arbitrarily speaking. 0.3 is probably too low. Let's go ahead and make it 0.6. Because the only softness that I really want is that core value. And even that's, we're probably going to end up staging that rather than leaving it as a simple value. Let's go ahead and hit randomize again. This is a very like 60s sci-fi sort of look. So you can see we've got some issues where our biome 1, which is blue, and our biome 3, which is that yellow, dusky yellow color, they're overlapping. And I think that's because the skew factor is exactly 1. So I've been setting the skew factor as a random range, but I forgot to tell it that those ranges are floats. And it's been giving us integer values, which is not the best. That's a little bit better. So these values are not quite as good as I want. What I think I need to do is we will be multiplying by vals.x at the end. Except I know it can be, because I do it all the time. That's so weird. Why is it barfing when it's down here, but not when it's up there? It's so weird. Oh, because this is a color 32, and that's a color. Oh, okay. We'll go ahead and do it as a color then. It'll become a color 32 when we return it. Now this is a little bit slow, and that's the biggest problem. It's slow even in by our standards. So we're going to go ahead and create some biomes that we can clearly differentiate. They'll give us a real Technicolor vibe, but that's fine. Right now we just want to be able to tell exactly what's going on. Okay, so basically my problem is that some of these biomes are clearly not working right, but I think that the issue is that now that I've introduced so much crispness to the first two biomes, now the next two biomes aren't really working out very well. So we're going to go ahead and bring back the blurriness on these guys. And then here with the vals greater than 0 and vals less than 0, we're going to make this 0.5f and else vals.w is less than negative 0.5f. And that should make it a lot more crisp. Let's find out. Possible mistaken empty statement. Empty statement? I don't see what you're talking about. Unexpected symbol call. What's it talking about? Oh. If. There we are. So, now we're going to try this one more time. No, need to regenerate it first. There we go. I'm still not sold on this. I think there needs to be more work done. I've been trying to create something that looks like it's biome data based on that, but it looks like there's some values that are not compatible, and they're really screwing things up. Let's go ahead and just remove the latter two biomes for a second. So the issue here is that I actually want these biomes to be based on the first noise values, because the first noise values are the ones where it's going to be at least vaguely correct. Which that is to say that's going to be like an actual association between those values and specific kinds of values on the main planet. But the problem is that if I do it with X and Y, it's not working out. So we're going to just go ahead and, for the moment, set this up to return a much less skewed setup. So here is where we get the biome.w and the biome.x, this stuff. These are going to be magnitude, and this is going to be magnitude. And that should be much more carefully associated with the actual XY, underlying XY calculations. And it should look better. We will see. Well, we got a very purple planet. So it looks like this one has mostly biome 1. There's some other biome stuff, but you can see this isn't very crisp. This doesn't really look like it's being properly broken into pieces. It looks more like it's just kind of an arbitrary cloudy situation, and we really do want to introduce some edges that are crisper than that. The easiest way to do that is to step these edges. And another easy way to do that is to offset them by some amount. But for I think now stepping is probably a better idea. So when we multiply by values.x, what we're actually going to want to do is multiply by values.x times 10. So mathf.rounded values.x times 10 divided by 10. That'll just give us a really easy way to give us 10 steps to our height. See? So this is not exactly what I want, but I wanted to show you the sort of thing that I'm trying to get. What we're really wanting to do is crisp up this part. So what we're going to do is we're only going to do this when it's near 0.5. So if vals.x is less than 0.4f, then multiply just by vals.x. Or vals.x is greater than 0.7f. There we are. Otherwise, multiply it by a stepped value. And I'm not sure that this is the right way to do it. I'm just kind of playing around at this point, just having fun, because why not? Oh, I pressed randomize. That was not what I wanted. Oh, well. So this hasn't finished recalculating yet, so I'll run one more time here. Recompiling, that is. There we are. So you can see that we have some blurry and some stepped. And, you know, I'm not convinced that that's the right way to do it, but it looks better than having it either all stepped or all blurry. Let's go ahead and take this down to 0.6. Later on, we can introduce lots of other coordinates or values or stuff like that. Just trying to get a feel for whether or not this can be made fun. Fun looking. And I'm having a tough time with it because it doesn't really feel very planet-like at the moment. It feels cloud-like. And that's a little bit tough for me. It might be that it just needs to be brighter in general. So if I take this and I say vals.x plus 1 divided by 2, that'll bring it to between 0.5 and 1 instead of black. Because the blackness should really be a biome, right? Now this is also supposed to be a height map, so it's partially because it doesn't look like it's a height map. I don't know. Someone sent me a link to a planet system. Yeah, that's like, I've looked at this before, and unless it's changed, it's basically the same thing that I tend to try and do, and it's not good enough. It's nowhere near good enough. It's decent as long as you don't look like it. We can change out the noise type to get slightly better noise types, which I mentioned a long time ago. But the issue here is that I'm trying to get biomes, things that simulate the idea of there might have been tectonic activity or ice or something like that. So what he's doing in his is he's taking a lot of offset noise values, and then he is just adding them together or subtracting them apart. The problem with that is that those noise values aren't connected, and that means that you don't end up with something that feels right, not to me. The whole setup looks okay if you're not. So if I wanted to just have a basic planetary setup the same way that he's got, what I would do is I would take a noise field, and then I would take another noise field and add it on top. And that gives you a very blotchy look. I can actually show it to you. Hold on. It might not be a bad idea to have noise field operators, but right now you can see here we do this z equals noise. If I just replace that with n0 plus n1, and I make sure that that this is multiplied by some larger amount. Hold on. It's if I just make this noise pause plus noise pause times 5, you'll see what he's doing. So this is what it looks like when I do the noise offset system, which creates these skewed and wrapped results. When you use the noise addition system, you get these kinds of results. Now, this is obviously a very, very high scale factor right now. So if I were to reduce this scale factor like this and run it again. So the idea here is that you can change exactly what sort of noise levels you're looking at to get different scale factors. I guess I need to make these. I'm trying to get the scales right to show you what he's doing. Oh, I went the wrong way, didn't I? This is more or less what he's doing. And these bright patches here are all surface, and then the lower patches are all mountains, are all rivers rather, or lakes, water. The problem is that this doesn't produce impacts; it just produces noise. But it might not be a bad idea to make something that's a little bit more flexible. So let's go ahead and do that. That's a great idea. Let's make this a proper industrial grade solution because there's no reason not to. So we're going to create a new C# script, which is going to be called noise field operation. And we're going to go ahead and put in a namespace planet. And it's not going to be descended from MonoBehavior. It's just going to be a class. And we're going to go ahead and make this a system serializable. So what we're going to want to do here is put in some values. So some of the stuff that's in our planet right now, let's go ahead and close a lot of this other. There we are. So we've got some of these values for our setup, which need to be in our new noise field operation. And the biggest one is going to be the noise function, which we can later on replace in order to make it so that this is a something that's not Perlin. Erdway says, hello, planets, woo! Yeah, well, we're currently refactoring some code, so it'll be a second before we get back into planets, but we have a couple of different kinds of noise field operation, and the basic thing that we want to worry about is exactly how to categorize that, and the easiest way is to make it an enum, public enum noise field operation type. And so what we're going to want to do is there are some basic kinds of noise field operation. One is generating a noise field, and the other one is how we apply the noise field, and those are both factors. So public enum noise field generator type. So those are the two enums we're going to need to have. And the noise field operation can be additive, additive, subtractive. It can also be an average. We can add other values later, including things like if over a certain percentage, use this value instead. We'll get to that, all that stuff later on. For now, that's fine. And our noise field generator type is going to be basic or skewed. So down here in our noise field operation, we're going to want those as enums, noise field operation type, and public noise field generator type, generator. This will be operation and generator. And those should automatically default to additive and basic. Additive always looks like it's spelled wrong, doesn't it? I don't know. So what we're going to want to do is when we are doing a noise field operation, we have to, there's one more important kind of noise field operation, and that is providing coordinates. Now, do I want that? No, I don't. We can put that in later if we need it, but it's a little too complicated for now. Basically, when we do a noise field operation, we're going to pass in a list of, we can either do this pixel by pixel or all at once on all pixels. Well, we'll just go ahead and make a virtual public float value, and we'll pass it in a vector to pause and a float crease overlap level. Now, in the other one, we used a vector 3, and our z was the crease overlap level. This is just the same thing, but it's split out so we can see it a little bit better. So right now, our color is right here. Pass that over here, as you can see. And instead of using this kind of, I've got to do it differently here. virtual public float value vector2 pos. And this is the stuff that's going to be in a vector2 pos. So we'll just go ahead and say return noise pos. That's not how you spell noise. That's ois. There we are. And then here we'll just say get value. Mix equals crease overlap level. Minus 0.5, that's create. Jeez, my fingers stopped working all of a sudden. And we're returning a float value rather than a color 32, so like that. All right, that should work. Now what we need to do is over here on our generated planet texture, we're going to take a list of those. Public noise field operation operators. And then down here in our setup, we're going to want to create a texture based on those. So we're also going to want a randomize function. We'll put that in right now so I don't forget. Virtual public void randomize. So here in randomize, we're going to go through all of our noise field operators and randomize them. So for each operator, noise field operation op in operators op.randomize. Elboechi says, hi Craig. Hello. We are creating some planet textures at this point, and we're just in the middle of refactoring some of our code. So here, when we do this, all of this stuff works great, except that we need to change a few of these values a little bit. And we're going to be going through all of our noise field operations instead of what we thought we were going to be doing. So the problem with this is it's only going to give us a final height map value, not a more complicated value like we would like. But for now, we're going to work with that. That's just going to be how it is. For each noise field operation op in operators, height, well, I guess we're going to go ahead and have to pass it the current value, aren't we? Because otherwise we'll have to do some calculation on the planet's texture side, and that doesn't make any sense. So height equals op dot value pause, and then I deleted it because I'm an idiot. So hold on, let's copy this and then undo a whole bunch of stuff because I didn't want to delete that. All right, so this. So I don't have to rethink about it later on. And then we'll redo, which is Control Y. Okay. And then the current value, which is height. There we go. So that should do. We shouldn't have any problems with that now, I think. Let's see if it barfs. No method for value takes one argument. All right, so is it barf? Math.lerp, main value, current value. Except for current value is, well, I guess it's okay. Got it? You done? Okay. So right now there are no operators. And if we generate it, it should be just black. Except for the fact that right now we are actually just getting a position element, not the height. So we're going to go ahead and just say pixels index equals color.white times height. We'll work that out later, right? And you can see that we have a nice pitch black result. The material is shiny, which is why we've got a little bit of shine to it. Let's go ahead and just take that down so that we don't have to worry about that. And then what we'll do is we'll add in an operator, 1. And you can see that we've got a couple of operations here that we can choose from, but none of them are implemented yet. So we'll just randomize, and there we go. We now have some values. Now the problem is that we're not currently actually having these noise field values have a noise field value. So public vector2 or public float scale equals 1 or 10, I don't know. Here in randomize, we'll adjust the scale. Scale equals mathf random dot range 1f to 20f, I guess. I don't really know. We'll just leave it like that for now. And then here, when we actually get the noise, we're going to multiply that by our scale. But that is not what we're actually going to be returning. So float val equals return val, because we actually need to take a switch based on our noise field operation type. Switch operation default debug.log error operation noise field operation type plus operation plus doesn't exist. Break. Otherwise, we're going to go ahead and go through each of these. Additive. We'll go ahead and return current value plus value. Noise field dot average. Return these, but divided by 2. And subtractive. Return current value minus val. Easy enough, right? And then here we'll just say return val. There we are. That should do. So now when we generate it, we'll actually have some random stuff happening, right? So there are some things that we're going to want to have a little bit more interesting and complex, as in everything is going to have to be more interesting and complex. But you can see that right now we've got quite a bit of stuff. If we add in another operator like this, then we'll have 2 additive operators, and a little bit of luck, we'll end up with something that's a little bit similar to what we had before, with the problem being that the scales on these are a little out of control. Yeah. So if we wanted to talk about generating planets with mountains and hills, this is how you would do it, but our visualization isn't quite up to par yet. So we're going to want to have a public float amplitude, and that's going to be a 1, but we can change it later on. So down here, when we get the val, we're going to go ahead and say times amplitude. That way we can add in smaller amounts of these values. So if we take a look at this high scale one, we can take it down to 0.2. And then when we run this, we'll get something like this, which is a little bit more like what you might expect if you're generating stuff. Now, if we wanted to do it, if we wanted to do something, what we could do is we could take an ocean thing and say if it's below X, it's ocean. There's currently no operator for just declaring something as ocean if it's under a certain percentage, because that's going to be on the planet rather than on the generator. At least I think so. But we could, because the noise field generator type can be basic, can be skewed, and it can be input only, in which case it's going to be a little bit different. So here, when we get the noise value, this is noise pause times scale. We're going to want to make this actually offset based on the kind of situation it is instead. So float val. So first off, we'll just say float val equals 0. Then we'll say val equals this. So switch generator default debug.log error noise field operation has no generator type, and then the generator. And then we'll return 0. Otherwise, basic, that's this guy. Otherwise, our input only, val equals current value. And then we're going to take skewed. And this here, amplitude, we'll put this on afterwards. So val times equals amplitude. So the skewed, as you might remember, involves finding a coordinate based on the xy noise values. So if we just take a new xy value, vector2 offset equals, or vector2 new pos equals our noise value pos times scale plus an offset. So we don't have an offset yet. We'll just add one in. And that offset is something we will add into everybody. So we can actually do it inside of our noise value. Yeah, we'll keep it outside for now. So pos dot scale plus offset. There we are. And this new pos is what we actually get our noise from. Something like that. Not 100% sure that's going to work out. Let's find out. All right, there we go. So what we're going to want to do here is we have an input only value, which we can just abuse at the moment. So we'll do that. We'll take the third element here, and we will make it a subtractive element based on the input only with a scale, with an amplitude of 0.5. And I think that will end up dampening the whole thing down. But down here in the random, let's go ahead and change the offset. Offset equals mathf dot inside random dot circle inside unit circle times and then the scale. No, we don't even need to. We don't need that's defined like this. I might make it times 2 later on, but you know. Yeah. So this has brought everything down because we currently don't have any thresholds. There's no if statements saying, you know, if it's less than this, then do that. So we're going to go ahead and put in a threshold. Min thresh, public float max thresh. If current value is greater than min thresh, or is less than min thresh, return current value. If current value is greater than max thresh, and max thresh is greater than min thresh, return current value. And that will allow us to only have operations that are applied at certain values. So in this case, for example, we can take this subtractive element and only apply it below 0.3. And that way we can flatten out our oceans. 0.3 turns out to be a little bit much, so because we're adding things together. So the point of this is that there's a lot of stuff we can do to make these things interesting if we use this kind of additive setup. Now, the problem with this additive setup is that it is not GPU friendly at all. While I can easily convert the old version into a GPU system, converting the new version into a GPU system is actually quite hard because it doesn't have any of the values that we need. It's got like this endless inside of, operators inside of operators arbitrarily, and that's not what the GPU is good at. So if I was going to do it like this, I wouldn't be able to move it to the GPU. But on the other hand, maybe that's okay. Either way, this currently just creates a height map, and that's a problem because I don't actually give a crap about the height. The height map is just there to create some surface material, to create some fun surfacing elements. What I really want is that awesome setup where it is like got crisp edges and planetary what do you call them? Large regions that have gotten the U.S. is on a tectonic plate. Yeah, tectonic plate. That's what I was trying to say. Idiot. All right, so we're going to take the random out of the scale here because it's a little bit not good. Yeah, working as expected. We can certainly change this up all day and all night. But the problem here is that we're not getting what I want. Now, one of the things I can do if I want to get something more like what I want is I can change this to skewed. When we run that, you'll see that the planetary objects are no longer what they were. And now what we've got is this curly cued, skewed stuff. And that's great because this really feels a lot more alien planety than the straight up noise field that we had before. Now in the original version, I actually skewed twice, but in this version, I don't have an option for a double skew, and I don't think there's a need for one. The reason we were doing a double skew was so that we could get these tectonic plates, and we don't need that because we're getting them via another operation. So the curly Q elements work fine the way they are. If we reduce the scale, oh, that's a little too reduced. There we are. I'm trying to find like, a nice golden level for this. Yeah, that's more like it. So now you can see that this is starting to feel like it could be a planet in black and white. There are some things in it that don't look quite right, like these are not likely to actually show up on planets. But what we can do is we can add in another operator, which we can make the same kind of subtractive operator, but instead of having a max thresh, it's got a min thresh. And its amplitude is... it's got also skewed, and its amplitude is 1, and its scale is 4. That's all fine. Let's go ahead and randomize this. Oh, that's interesting. So this subtractive element is too strong. I'll take an amplitude down to 0.1. That ended up a very different scale than I thought it would. That's interesting. I thought I had made it so it didn't change the scales. I think we might still be using a scale from our planet. Are we multiplying by a scale here? Yeah, scale factor. Yeah, so we're still randomizing our scales and stuff here. We're going to just delete that because it's getting in our way at this point. Because I'm trying to generate some planets that look good, and I don't need that thing randomly varying. Let's go ahead and increase that a little bit more. I think it's increase or decrease. We'll find out. 250. 250 is the wrong direction. 80. There we are. So we're trying to figure out a good look just by playing around with this goofy stuff. These are all very effective ways to generate planets or whatever you're trying to do. The question is, how does it look good and when does it look bad? But we also have an issue where I do need to start thinking about biomes. Now, what I'm doing right now is I'm returning just a height value on this planet. And the problem with just generating a height value is that it doesn't tell you anything about the final colors you need to use. So in order to do that, I'm going to need to generate some other values. And there are an infinite number of values I could generate on a planet with air. It could be things like temperature, foliage, water. On a planet like the moon, a planetoid like the moon, it might not be. It might be something like asteroid impact zones and stuff like that. So when we're generating what sort of colors we want, we have the situation where how do we actually generate colors? Do we generate colors by overriding the color that comes in with a color of our choice, at least partially? Or do we do it by returning biome values, like a big stack of biome values? I think it's probably best if we have fun with colors instead of returning biome values. So all of these noise field operations, they give a current value. We're going to want to return a current value and an absolute color, I think. So this float, it's going to be a void. I'm going to take out current value and out color 32. And that's going to have to be in this as well. Out current value, out color 32 color. So here we'll go ahead and say that current value equals main and color equals get color main. And then down here we'll do the same thing because we can't return these anymore. So instead we would say that the current value minus equals val. Current value equals current value plus val, and current value plus equals val. Return. Excuse me. I hope that wasn't loud. So now we have the ability to get the colors. We're going to want to go ahead and say that color equals get color main. We're never going to need to do that, so that's fine. Public virtual virtual color 32 get color float value. So this is the part where we can inject a color if we want. The problem is that I'm currently taking a height, not a biome factor. So we're actually going to want to pass it in both the current value and the original value. So that's a delta we're getting. Our value float original value. We'll say float delta equals our value minus original value. If delta is not equal to 0, then we'll just return our color. We don't have a color yet. That's easy enough. We'll fix that right now. And another thing we can do is we can always change this to have a different alpha. So when we get the color, instead of returning the color, we're going to return a color.lerp. So return color.lerp. We don't actually get past the original color, do we? Because we're an idiot. So this should be float delta, float arc. Sorry, I'm thinking about how to do this. But that's okay. So we're going to pass it the color rather than the way we're doing it here. That way we know what the original color was. So return color.lerp color, no, original color. Original color, color, and then mathf.abs delta times 2. Something like that should work fine. Why are you red? Looks like a fat fingered something. Oh, look at all those values I didn't get right. Oh, these are, I have to factor it back in. So when we pass the values in, we have to pass it the color and the current value. So this is out height and out pixels index. I'm not sure if you can do that. I think you can, though. We will find out. And then at the end, we go ahead and say that pixel index equals whatever it is times height. So we'll go ahead and create our own color. Color 32C, color C equals color.white. We'll pass it out here. And then down here, we'll go ahead and say C times height. Maybe. We'll figure that out later. Now, there should still be some errors. Yeah. That shouldn't have... Oh, because I'm taking a color rather than a color 32. Let's go ahead and... I don't know which of these... Color 32 is much better in terms of speed, but we're generating this and then saving it, so I'm not sure there's any reason to worry about absolute speed here. As long as it can happen in less than a couple of seconds, it's fine. So here we need to pass it in out current value, out color, float old current value equals current value. And then this is just value out current value out color. Then we're going to go ahead and use old current value for the current value here, old current value. Int old current value equals current value. Problem is we're overriding current value, and that means that we're doing a lot of very silly stuff. Oh, this doesn't need to have the color. We never use the color in here. Okay, so the problem right now is that we're passing in a lot of out current values, and I think we don't want to do that for all of these, because that's not great. Let's go ahead and rethink how we're doing this. We want the original to be an out, but in here, we want to actually return these values. So we'll undo the changes that we've created. And then up here, what we're going to do is we're going to go ahead and float main equals current value, no color argument. And current value doesn't change, and that's important. So in here, when we say current value equals mathf.lerp, current value, we're going to make this main, and then we can say current value again. Because I was overwriting it midstream last time, and it was all screwed up. So this is going to be main, our current value. This is going to be main. There we are. I think that'll work better. I'm pretty sure. So current value in this case is not actually established because it's an out. I need it to be, is it ref? Can I do it by ref? I think I can do it by ref. Do I have to put an ampersand? I can't remember. I use too many languages, and I can never remember which ones use which modifiers. Oh, this doesn't return a color. It just overwrites a color. And this is a ref. And up here, we got to pass it via ref, right? Well, I made lots of dumb mistakes there, but let's see whether or not I can get this to work. So we've got these color values, and we can set them to whatever we want. But if I leave them empty, what we'll be doing here is when we lerp, we're going to multiply by the color.alpha. And that way, what we'll have is if it's black, if it's transparent, it doesn't get applied, right? Sound good? So here, when we do the subtractive, we're going to make this ice blue and make it completely opaque just to see whether or not that works. Because in theory, it should make the surface of the planet blue instead of black, except that we're multiplying it by height. And that's going to be an issue. So back here, we have this situation where multiplying by height, and height is 0, and that means it's black. So we're going to want that to not be the case. To be honest, height is a height map thing. It's not really supposed to be... we'll just go ahead and take it out. Just testing some stuff first, so... All right, so there we are. So you can see that it made the things that are down on the bottom blue. It also completely barfed the far side of the planet, which is not what I expected. We'll have to figure out what went on there. But either way, the point is, well, I know what went on there. I screwed up the noise field operation here with the value. So I get the max current value equals. So here is the problem. Main equals. There we are. That should fix it. But we do want to have some fake version of height offsets in here. So we're going to just go ahead and multiply by some height-like value. Just to give it a sense of depth. It's really supposed to be a height map, but we don't have a height map for this texture, or for this material. So we're not using it. And generating an actual like bump map is annoying, so we're not going to. All right, there we are. That's better. So now you can see that what we've got is a situation where we have oceans or something akin to oceans, and everything else is still proceeding apace. If we wanted to, we could go down here into this skewed subtractive, and we could give it like a green, a bright, vivid green. And then when we run that, you can see that it creates green valleys. I guess that's too bright. There we are. So you can see that creates some green valleys underneath our mountains. Our mountains are still very blobular. They're not quite mountainy enough. There are a lot of ways to fix that, and the easiest one might be to simply add in another set of mountains like this. So if we take in this fourth operation, we can make this additive. We can add in a basic with a high scale, like maybe 25. Amplitude of 0.1, let's make that 0.2. Also, we've got down here in our color situation, we have to actually divide by our amplitude, or rather multiply by our amplitude. Oh, divide by our amplitude. There we are. So with that in mind, we can take this and make it like a snowy white. Huh, that's interesting. Not quite what I thought would happen, but it's not too bad. Oh, I've still got, that's the problem. I've still got the minimum and maximum thresholds turned on. So if I were to change these thresholds to like 0.8. Ah, there we are. That's a little better. So there are lots of things you can do to try and make this look the way you want it to look. And I can even do things like when something changes, I can fire off this event so it recalculates. But as you can see, it takes a good second in order to recalculate. So it's not something I can just do willy-nilly. Now that time it takes to recalculate is almost entirely applying the texture and running the running the noise operation. The Perlin noise is not the fastest of operations, and that means that we do end up with a lot of extra crap. Lots of time's wasted on it. Now, one of the other issues we've got is that we have these real crisp edges, as you can see, because that's what happens when we have a minimum and we just say, oh, below the minimum, don't apply yourself. So what we're actually going to want to do is make it so that near the minimum you get applied less. We'll say within 0.1. So when we do that, we're going to take these values, get the value here within 0.1 of thresholds is val down. If current value is less than min thresh plus 0.1f, then val equals mathf.lerp val 0 current value minus min thresh times 10. I guess it's the opposite, min thresh, no, yeah, min thresh minus current value times 10. Otherwise, if current value is greater than max thresh minus 0.1f, then we want the same thing. And that way we won't get these really, really ugly, crisp edges that you can see. Let's see if I can get close enough that you can actually see what I'm talking about. These guys here. These crisp edges here are no good. And we do want crisp edges, but only in certain places. So if I hit run again, oh. Well, since I didn't change anything else, this must be the problem. Let's go ahead and comment them out just for a second to make sure that they are in fact the issue. Yeah, okay. So I screwed them up somehow. Oh, I see. The problem is that I'm actually applying them. 0 is actually the value that's going to be applied, not the amount of change. So we're going to actually have to do something else here. Val is going to have to be, instead of being between 0, it's going to have to be between current value and val. That makes a lot more sense. But that still shouldn't have fired that much. I think one of these is firing too much here. If current value is greater than max thresh minus 0.1. Oh, there's the problem. And max thresh does not equal min thresh. Because I had a lot of max thresh zeros just by default. Whoa. What the heck? I've got some kind of super basic screw up here that I'm not seeing because I'm not focusing enough anymore. So it looks fine when we're doing it with the min thresh. It's only when it's the max thresh that things screw up. So if the current value is greater than the max thresh of minus 0.1f and the max thresh does not equal the min thresh, and the max thresh is greater than the min thresh, that's the problem. Come on, run. So that should have dealt with it, but it looks like it didn't. You can see that we still have these. Oh, I guess they're a little bit blurred. I thought for sure they would be substantially more blurred than that. So down here, I've got the situation where our min thresh is 0.8. So within the range of 0.8 to 0.9, it should blur 0.8 minus current value. Min thresh of 0.8, current value. Okay, so this is actually negative. That's the problem. It's current value minus min thresh, and then up here this is max thresh minus current value. Nope. No, that seems to have made it substantially worse. So is this again the problem with max thresh specifically? I don't know why my brain just stopped working. I guess it's been 2 hours, and that's generally when it happens, but holy crap. That's pretty funny how aggressively your brain just shuts down. My brain just shuts down at a certain point. It's like, I don't know anymore. I completely give up. Okay, so that looks like a min thresh is also causing this issue. Well, what happened? Where'd our planet go? All right, so current value is less than min thresh plus 0.1 f, and min thresh is greater than 0. Then what we want to do is, if our current value is 0.9 and our min thresh is 0.8, then we want to take 0.9 minus 0.8 times 10, so that would be a 1. And if it's 8.5, we have 8.5 minus 8. That would be 0.5 times 10. No, it would be 8.5. Okay, so it's actually not putting it 8.5. It's 0.85. So that would be correct. That should work, right? Where our God damn it, brain! You got to stop shutting off after 2 hours. Oh, I forgot to let it recalculate, recompile. That should work. Why isn't this working? That's interesting. So all I'm trying to do is make it so that this thing here isn't quite as sharp. The reason it's sharp is because that value goes from being from just below 0.8 to just above 0.8. So over here, the min threshold, if the current value, which would be like 0.81 or 0.79, is less than the min threshold plus 0.01, so that would be 0.9, and the min threshold is greater than 0, yeah, that's fine, then the value equals a lerp between the current value and the value I'm trying to create equal to the current value minus the min thresh. So 0.81 minus 0.8, so 0.1, times 10. 0.01. So 0.01 times 10, that would be 0.1, right? I can't see what's wrong with this. Scale equals current value minus min thresh. So that would be like 0.1, below 0.1, because I'm doing this from a scale of 1 here, 0.1. So if this only happens if they're within 0.1 of each other, because if current value is below min thresh, then it doesn't run. And if current value is below min thresh 0.01, then it's going to be between min thresh and min thresh plus 0.01. So that means that if I take the current value and I subtract min thresh, I should have a value between 0 and 0.1. So when I multiply that by 10, I should get the result I want, but I'm not getting it. So what we're going to do is we're going to reduce the size of our texture. And we are going to put in a log. So that didn't fire at all. Okay, there we are. So here you can see we've got a couple of scales where it says a scale of 0.03, 0.02, 0.5, 0.6. All of these seem correct. There's nothing that seems extremely high or extremely low. There's a couple of very, very tiny outliers, but that's expected. So these scaled values are correct. The question is, why is this producing something that I do not think it should be producing? So it seems to be creating a situation where we have a lot of dark green areas when we shouldn't. Why is this? And a lot of really bright and a lot of really dark areas. Val equals... Oh, because I'm adding. You see, the problem is I am an idiot. Better. Fucking idiot. Yeah. The biggest problem with coding is that you're not very smart. No matter how smart you think you are, or how smart people tell you you are, you're not. Nobody is. All right, so we've got this situation where we've got some things going on here, but what I think I'm going to do is this subtraction. I'm going to go ahead and put in a weird min and max thresh just to see what happens, and we'll end up with some threshold stuff running out into the water. Oh, so here you can see we've got some ice cap stuff happening, which is interesting, because we're adding in a lot of values down here at the 0.8 level. And so the end result is that we're getting a lot of ice caps. And that's kind of what I was aiming for. But we also need to add in a new set of features for north and south equator elements. So let's go ahead and take this back up to 0.68. And then we'll add in a... what is it called? Is latitude the one that goes up and down? I can't remember. Latitude. Latitude, yeah. So, latitude. So with latitude, we can just call in for how far above zero we are. Case latitude. And then we'll go ahead and say that the val equals the latitude. So it's not going to be just latitude. We have to absolute value it. And we're going to be taking in the pos.y here. The problem is that this pos.y is arbitrarily scaled by our upstairs neighbor. So what we end up with is a value that is between 0 and however many pixels high the original was. And because of that, it was time for us to change our scaling here into something besides pixels. And that's going to be just a matter of taking these x and y values and dividing them by the width. So y divided by height and divided by width. Now that's going to end up radically increasing the size of this. Do I have height? Oh, float height map. It's going to end up radically increasing the size of this because now the scaling is all wrong. But let's go ahead and just take a look and see it. Yeah, you can see how that's just ridiculous. So if we increase the scaling on our planet to like 2000, that might be better. I can't tell. It's either better or worse. Oh, because we're actually not scaling. It's not, the scale is inverted. So we're going to just go ahead and uninvert it. I don't know what the values we're using are is the problem. So what we're doing is we're finding the scale here. The position is going to be between 0 and 1 for all of these. Actually, it's going to be between negative 0.5 and 0.5 for x, sort of. But y is going to be between 0 and 1, or negative 1 and 1. Or, no, it'll be between 0 and 1. Well, that's a problem. So this is supposed to be y minus height divided by 2 times 2 divided by height. That seems a little odd, though, doesn't it? That can't be right, can it? It seems weird. We're just trying to get a raw unscaled y value because right now it's scaled by number of pixels, and that's dumb. So it really should be, let's go ahead and just say y divided by height plus, so this is between 0 and 1. I want to multiply it by 2 and then subtract 1. And that'll get us a value between negative 1 and 1 for the y, and that's correct. And then we multiply that by our scale factor, which currently is 200. It may just be that the scale can't be a integer value. There we go. So that's more like what I expected to see. Obviously, our scale is currently too big. Let's make it like 100.1. All right, now we're getting somewhere. Still a little too big. How about 40.2? Okay, now we're getting there. This is more like what I hope to see. So we've got the situation where we are creating an ice value for our element 4. So what we're going to do is instead of making it an ice value, we're going to want to make it into a latitude value. But for some reason, the noise field generator type didn't get updated. Maybe I didn't save it. There we are. So once we've gotten that latitude, we're going to want to make that the absolute value of the position.y, and that'll work fine. And then what we can do is we can say that our minimum is 0.8 and our maximum is whatever, it doesn't matter. Scale of 6.8 doesn't matter. Amplitude of 0.2 is fine. We can also make it whatever we want. 1 is fine too. And that will actually end up creating a North Pole and a South Pole in theory. It's latitude. Doesn't seem to be doing anything. All right, well, what if we remove that for a moment? Am I still printing scale stuff? I shouldn't be. I think that's just left over. Yeah, it's just left over. Okay, so it looks like I have something else that's creating this white effect. Or this isn't running anymore. Not sure. Oh, good. This is great because it means that if we change the scale of the texture, we actually still get a fine result. So if you take a look, if I do this at 256 by 256 and generate it, I'll get this. And if I do it at 1024 by 1024 and generate it, I'll get the same map, but in higher resolution. And that's kind of the point. See? Now the problem is that one of these things is malfunctioning because these should not be 1. So something has brought them to well above 1 at some point. But these are both amplitude of point. Oh, this is an amplitude of... There's the problem. Oof, there we are. So now our water level is much too high, as you can tell. So we're going to bring that down to like 0.5 or so. And this guy can have a min thresh of like 0.5 and a max thresh of 0.8. Well, something like that, right? I'll just go ahead and hit run. So it looks like our water is not quite as hardy as it needs to be. We can work that out later. For right now, what I'm trying to do is just trying to get the caps to work. That's interesting. I wonder what's going on here. So this should be water that is ice cold, but we're getting some kind of subtractive element. I think it's this guy screwing it up somehow, but it shouldn't be able to. No, that's not it. It's all good. Whatever. For now, we'll just leave it like this, and we will work out exactly how we want it to work in a moment. Because I want to get the latitude tested. So what we're going to do is we're going to take an additive latitude with something we can see, like bright red, just to tell whether or not it's working. And we're going to go ahead and have a min and max thresh just to see whether that's working. Make our amplitude 1 and run it. So you can see that this is not latitude based. There's something wrong with the latitude engine, and it's not latituding. This weird white stripe, I'm not sure what's causing that. But here in the latitude system, we're taking pos.y as our value. Here's pos, here's y. When we actually pass that value over to, I think we're multiplying it by something, a scale factor. And that must be the problem, because the scale factor of the planet is interfering with the scale factor of the individual objects. So we'll just remove the scale factor of the planet for the moment. And then we will have to change the scale factor on all of these sub-objects, obviously. Okay, so all of these need to have their scale radically increased, I believe. So from 0.5 to 20, and from 2.4 to 120. And this can be 120, 100. And then this can be 100. I don't care. This doesn't have to matter, so that should work. Right? Should all work. Okay, obviously it needs a little bit of work, but you can see that the latitude system now actually functions. If we go ahead and we take this latitude function and we bring it down to 0.8 as a minimum, and then we should allow it to 0. It should allow it to be a little bit more crisp, but you can see how it only takes effect. Oh, it stopped working entirely. Okay, so it only takes effect on the lower or upper. It only takes effect on the upper areas, as you can see here, because it's only getting applied to the upper values. This isn't a min threshold of what amplitude gets applied. It's a min threshold to the current height map that gets applied. So when I run it this time, we're going to see that it works, but it's obviously dumb. So what we would actually want to do is move this up, except for I don't believe that it supports drag and drop in this particular setup. Still, you can see the basic idea here. Now, I basically burned myself out doing this for today, so I don't believe that there's anything else on the menu, but I do want to try another planet. Now, one of the issues we've got here is that we have a whole bunch of stuff we're no longer using. We might as well get rid of. Anytime they're mentioned, we'll get rid of them. So all of this stuff. All right, now I move this over. There we go. We got a new one. And we'll just start this entire thing up from scratch. So first things first, we'll do the latitude as a big white ball. Except that can't be first, can it? It has to be second. Okay, so first we'll do a basic setup with a low scale. Just to see, that should work. And then we'll just randomize it, and we should get, some noise. That's too high of a scale, so let's make it 15. So for some reason, it's really wide. Is that because it's got a high Y scale value? Nope, it's still really wide. Oh, of course it is. The pixels need to be 512 by... Okay, so that's actually not the case. The problem is that there are twice as many X as there are Y, and I'm not taking that into account when I actually scale this. So I'm just going to stop this X width divided by 2 times X scale. I'm going to go ahead and refactor this to be X divided by width come on, times 2 minus 1. Times X scale times 2. Well, it looks like something's gone wrong with the y-axis and the x-axis. It looks like everything's gotten borked. Yep. That somehow made it not work. Now it's mirror imaged across the x and y axes. What? Oh, x divided by width, which is going to be 0 to 1, times 2, 0 to 2, minus 1, negative 1 to 1, times x scale, times 2. Well, if we remove the times 2, is that really going to fix it? This doesn't make any sense. Why would it be mirroring on the x and y axes? No, it's still mirroring on all the axes. Has it always been doing that and I've just now only noticed? Okay, I have to stop. I can't think anymore. So thanks for stopping by, those of you who did. If you have any more questions, let me know. But I'm going to stop now. My voice is given out anyway. The fact that these are mirrored across the x and y axes is really strange because we're not doing anything that should mirror them. The only thing we're doing is, the only absolute value we're passing is the absolute value that tells us how much overlap to have. Now these should be mirrored at only one part. They should be mirrored on the x-axis at the seam. But they shouldn't be mirrored anywhere else. And this guy, for example, he's not. There's some off-center stuff going on. But this guy's a perfect mirror. And that's not how it's supposed to be, and I don't know why it is like that. Okay, so here you can see it's not a perfect mirror. This seam is the only part where it's supposed to be a perfect mirror, and I may have just gone a little too far with making this actually happen properly. So if I take this noise field operation that bounces it, I can make it bounce much more aggressively only at the most important amplitudes. So there we are. That was the problem. I was checking to see whether or not it was negative after doing a whole bunch of multiplying. So hopefully that should work. We will see once it's done recalculating it. There we are. Hit run. Wow, that changed jack shit. Wonderful. So if I bring the scale down to like 6.1, I think that I know what the problem is. See, that's not centered at all. That actually works, and it's clear that the x still needs to be doubled. So my attempt to not double the x to fix it obviously did nothing. So I think the problem is the amount of the offset being too low when our scale is too low. So we end up with an offset that is just inside of a unit circle, and it needs to be substantially more offset, I guess. See, here we've got, again, with the almost perfect mirroring. Now that is the seam. So, I mean, that's the place where it would be perfectly mirrored. But it's also perfectly mirrored over here. Is this the seam? I don't even remember which part's the seam anymore. But either way, we're having a perfect mirror at the x coordinates. And I think that the problem is that. So we're going to go ahead and run it again. I think what the issue is, yep, I knew it. The problem is that when we're calculating noise fields, when we use a negative value, it bounces off the 0 plane. So when we calculate out an offset, it has to be positive because otherwise you'll bounce off the 0 because the noise field is actually mirrored across 0. So when we randomize, we're going to want to add in a vector2.1. There we go. Now the mirroring is much less obvious, except for it still seems to be bouncing off the y-axis. Oh, because it's like, did I pressed random, right? Oh, I was trying to change the random. I changed the wrong function. I should stop trying to do stuff when my brain stopped working. There we are. That's what I meant to change, you idiot. There we go. Better. All right, so we do still have the crease, and it's noticeable, but it should be a lot less noticeable than before. This is more or less what we're supposed to be seeing. Now you can see there is some mirroring, and we can try and avoid that by offsetting by substantially larger values. So offset times equals, or even, I know what the problem is. I actually need to add more than vector 2.1 because the problem is that we run from -2 to 2 for the x-axis and from -1 to 1 on the y-axis. So we've got to make sure we never bounce across the 0. There we go. Now we've got no 0 bouncing. The only 0 bouncing we have is over here, and it's not really 0 bouncing. It's a bouncing that we have to do in order to get the seams to line up. But that should be the only spot, and it shouldn't be too egregious. Now if we add in another operator, this doesn't need to be white. It can be like yellow. And then this operator down here, we'll take the latitude and we'll add in just a flat white to give us an upscale latitude there. And this can be reduced down to like 3.2. And then we can just, oh, darn it. And we'll make the 3. This will be additive. So this will be amplitude of 0.5. And then this will be an amplitude of 0.5 with a much higher scale, something like 50. Skewed. And let's try it out. Oh, that's not what I expected. Is this skewing? Does this have to be just big? Is that the problem? I think that I know what the problem is. I think that when I changed it so that I was no longer using pixel coordinates, the skew broke. So here's our new pause, right? And our new pause is noise, pause time scale, noise, pause time scale plus offset. I'm not sure. But then we do this new noise pause time scale, and I think that we've got a problem where the scales are getting all mixed up here, and it's ending up doing something dumb. And I can't tell which direction it's doing something dumb in. Okay, so it was doing something dumb in the other direction. That's fine. We'll go ahead and make these green. Or maybe we'll make them like a red, a russet red. Oh, that's a little bit more severe. So what I've done here is I'm testing out how it works with adding on latitude elements. So right now the problem is that I'm adding in this russet red, whether or not I am adding or subtracting but I'm carving out this height here, and it's not working for me. So let's change this to 0.9. Now the value is probably over 1, so it should be kind of an interesting situation. Okay, so it looks like the lerping is backwards, and that was the whole thing I was whining about the whole time last time. I just had backwards lerping on our noise field operation. So this is going to be current value minus the max thresh, I guess. Is that really right? I guess it must be. Come on. Well, that didn't actually take at all, did it? So I guess I need to... Oh, it's 0 val. There we go. That's what I wanted to see. So now you can see I've added in some edge softening here. And I've got myself some stuff. And now what I can also do is I can use a similar value if I want to have the equator look a little bit different. The problem is that I don't have an inverse latitude number or something like that. I'll have to figure out what I want to do for that later. But this here doesn't have any continents. So the problem is that our basic additive element is a little bit too weak. So what we're trying to get here is some continents and then some rivers or something, you know, waters. Let's go ahead and make this into input only, and then that should subtract out everything. So we'll go ahead and give it a minimum threshold of, oh, 0 is good there, and then 0.5 here. That should make it so that it flattens out. Interesting. No, that's correct. So the reason we've got such a muddy situation is that I'm playing with numbers that are well over 1. And the problem is that anything over 1 is just rendered as 1, even though the math continues to let it be over 1. I'm not sure whether or not it's a good idea to allow for values over 1 and below 0, even though they get rendered flat at the end, just because it's hard to remember in your brain when you're doing this stuff exactly what's going on. So anyway, then what I'll do is I'll add in the additive skewed inputs for our mountainy stuff. Ooh, that didn't quite work. Ah, I got the inputs backwards. That should be 0.50 rather than the other way around. Ah, that's more like what I wanted to see. So the river area is a little bit flat, and the reason that it's flat is because it's only taking input, meaning that it's not doing any sort of other operations. But I can certainly add in some more value here. Right now I've got this so that I can just do this, and then instead of being white, I can make it black. And this will be subtractive. And that gives us a really super crisp edge. If I want to weaken the edge, I could always make it additive instead of subtractive, just because that would be a little bit less obvious. Or I could make it so that it crossed the edges and didn't have two entirely separate operators. But you can see that the basic idea here is I can use the basic non-skewed operators to create continents and mountains, and then I can use the skewed operators to create surface details. And once I find like a golden ratio for these, I can always figure out exactly what I want to do, you know. But for right now, this should work out. We'll go ahead and do this 0.9, just so that we don't have it quite as... Yeah, even 0.9 is a little bit much. We'll go for 0.8, 0.7 even. And then this, we can just have it scribble all over the planet with black pen if we want. Brah. If we reduce the alpha, it will scribble less. In fact, we reduced it so much that you can't really even see it anymore. But the point here is that you can do a lot with this and have it be fairly interesting and fun. So if I were to change this to be, instead of a pitch black like that, which doesn't really look very realistic, we can make it like a bright yellowy color and increase the opacity a little bit to just add in some shine on the upper levels. And you can get a little bit of stuff here and there that starts to look like biomes, right? And you can see that if you were looking at this planet, the first thing you'd think is, okay, it's got ice caps, and it's got ocean type places and stuff like that. Now, the actual values for our surface are a little bit bad, just because they are, well, first off, let's go ahead and make this multiplied by a big ass value, a random value, random.range 1 to 100,000. But basically, I'm trying to think of the best way to make this look like it's a planet that's worth inhabiting. And right now, one of the issues we've got is that our continents are a little bit too continenty. So it might be worth having it so that the operator can have, instead of just basic, it can also have something like squared or something similar. But we can also go ahead and take this subtractive element and put it up to like 0.8. And that will reduce the surface area of the continents. Now, in turn, that creates a lot of jitter, but maybe that's what we want in this particular case. So what we get at the end here is a situation where we can customize the planet to some extent, and I can create like packs of modifiers that get applied willy-nilly. Now, the amplitude of the scale here is quite low. If we up the amplitude, we'll end up with bigger ice caps. See? So we can choose how we want that to be there. But the one thing I definitely want to change right now is that the latitude, I'm going to square it. Oh, in fact, I don't have to do the math.abs if I'm squaring it, so... Just because otherwise it starts too low. There we are. So now our ice caps are nice and ice cappy, and the rest of our planet is not. And we can also try inverse latitude and stuff like that if we would like. If we reduce the additive value here's scale by enough to like 1.3, then we'll get just a few blops. We'll get just a few blops, and it'll look like Pluto or something, where there's just a couple of shapes on the surface, and then the rest is just random charred nonsense. Hearth Gaming says, what is this game? Well, right now I'm just working on a planet generator for it, but it's a space game where you fly spaceships around. This is not an episode that I've spent working on the spaceships, though. I'm just trying to create a planet generator that doesn't suck too bad, and it's sometimes a little difficult. So I'm trying to create planets that have biomes. And as you can see, this planet has like some stuff going on. It's got ice caps, and it's got this skewed part here, and then it's got this fuzzy part here, and then it's got this weird flat basin. And that's kind of the point. But I think I want to add just a little bit more chitter chatter. So we're going to add in one more set of operators for another skewed aspect. This one has a scale of like 7.1. And we will not have any min or max on it. Might be a little too much. Let's go ahead and reduce this color down to 0 alpha so that it doesn't change anything's color. It only changes the height map. Ah, that's a little bit better. That way we don't have a completely dark basin. But I still think this is a little bit too low scale. So we're going to increase the scale. And run it again. That's more like what I wanted. And that way we can chop it. You can see how we can chop it apart like that. That should work pretty well. And if we completely randomize it, we should just get a different set of results. But that super low scale blop, as the additive blop in the beginning, makes it so that we have a very, very simplistic planet with huge regions. If we increase that, we'll get more details like this. So this is a fairly decent way to work up some kind of planet. And nobody playing a space game is going to look at a planet like this and say, oh, it sucks. They might, but if so, they're really, really aggressive. But you can see the basic idea here is we can have this look a lot of different ways whenever we need it to. And what I might end up doing is having this hard-coded instead of having this scaling thing here, because I think what I really need is a really low scale and a medium scale and then a high scale and then a whole bunch of other operators. Hearth Gaming says, what language are you making it in? Well, I'm making it in Unity, so it's in C#. Well, now that I've spent the entire episode, hours and hours, doing that, let's pop back on over into the actual game world and just refresh ourselves on the fact that this game doesn't look too bad when you're not staring at a weird black screen. So I haven't finished integrating the big armor slabs into the physics yet, but everything seems to be running fine. We're running a little bit slow just because I've gotten some extra nonsense in. There's some LOD stuff that we're going to be doing, I think soon, maybe next week, where we're going to improve the LODs on these a little bit better, a little bit more, and also add in some LODs for the larger armor chunks that don't currently exist. And this was what we were working on in terms of creating ship components. Still got a lot of work left to do there. I'll have to think about the best visuals for that. But I don't want to spend too much time on it. I'm hoping to get this prototype at least out by Christmas. Well, I think I'm done for the day. My voice is given out and my brain stopped working an hour ago. So it's time for us to say goodbye. I'll hang around in the chat if anybody has questions in the near future. But otherwise, I'll see you next week on Wednesday or Sunday.